Uniform corrosion. This is considered the most common form of corrosion wherein an attack on the surface of the metal is executed by the atmosphere. This extent of the corrosion is easily discernible. This type of corrosion has a relatively low impact on the performance of the material. For example, a piece of zinc and steel immersed in diluted sulfuric acid would usually dissolve over its entire surface at a constant rate. Hydrogen grooving. This is a corrosion of piping by grooves that are formed due to the interaction of a corrosive agent, corroded pipe constituents, and hydrogen gas bubbles. The bubbles usually remove the protective coating once it comes in contact with the material. Metal dusting is a damaging form of corrosion that occurs when vulnerable materials are exposed to certain environments with high carbon activities, including synthesis gas. The corrosion results in breakup of bulk metal to metal powder. Corrosion occurs as a graphite layer is deposited on the surface of the metal from carbon monoxide (CO) in the vapor phase. This graphite layer then goes on to form metastable M3C species, where M is a metal that usually move away from the metal surface. In some cases, no M3C species may be observed. This means that the metal atoms have been directly transformed into the graphite layer. Microbial corrosion, which is also known as microbiological influenced corrosion. MIC is a type of corrosion that is caused by microorganisms. The most common one is autotrophs, both metallic and non-metallic metals, either in the presence or absence of oxygen, can be affected by this corrosion. High temperature corrosion, as the name suggests, is a type of corrosion of materials, mostly metals, due to heating. Chemical deterioration of metals can occur due to a hot atmosphere. Chemical deterioration of metal can occur due to a hot atmosphere that contains gases such as oxygen, sulfur, and other compounds. These compounds are capable of oxidizing the metals in this case easily. For example, metals used in car engines have to resist sustained periods at high temperature, during which they can be affected by an atmosphere containing corrosive products of combustion. What are the prevention methods of corrosion? Preventing corrosion is of utmost importance in order to avoid huge losses. The majority of the structures that we see and use are made up of metals. This includes bridges, automobiles, machinery, household goods like window grills, doors, railway lines, etc. While this is a concerning issue, several treatments are used to slow or prevent corrosion damage to metallic objects. This is especially done to those materials that are frequently exposed to the weather, saltwater, acids, or other hostile environments. Some of the popular methods to prevent corrosion include electroplating, galvanization, anodization, passivation, iofilm coatings, anti-corrosion protective coatings, painting and greasing, use of corrosion inhibitor or dyeing agents, periodic cleaning of metal surface, Electroplating. The main purpose of electroplating is to improve appearance, protection against corrosion, special surface properties, engineering or mechanical properties. In this process of electroplating, the anode is connected to the positive terminal and the cathode metal to be plated is connected to the negative terminal. Both are immersed in a solution that contains an electrolyte and then connected to an external supply of direct current. When DC power is applied, the anode is oxidized. Its metal atoms dissolve in the electrolyte solution. These dissolved metal ions are reduced at the cathode and form a coating. The current through the circuit is adjusted so that the rate at which the anode is dissolved equals the rate at which the cathode is plated. Different metals can be coated using the electroplating process. Passivation. It improves applying an outer layer to a material to protect it from harmful reactions such as corrosion reaction. The layer may occur spontaneously in nature through a process called self-passivating, or it can be reduced to the material as a micro coating. In this case, a light coat of a light coat of material, for instance a metal oxide, is used to form a shield against corrosion. In microelectronics, passivation is useful. Passivation is useful in the enhancement of silicon. The great practical significance of passivation is that it protects structural metals from rapid corrosion that occurs in freshwater, moist atmosphere and aggressive chemical mediums.